Alright, let's go ahead and get started with Lesson 3, Significant Figures. In this particular lesson, we're going to learn about how many digits that we need to record when we make a measurement. There might be times in past labs or past classes, even in your math classes, that you were supposed to record a measurement, or you made a calculation and you get all these decimal points in your calculation and you ask yourself, okay, how many decimal points do I need to record, or how many digits do I need to write down? Well, that's what this lesson is going to help us with, is to teach us how many digits that we record for any type of measurement. So the thing you have to understand is that the tool that you make the measurement with, whether it's a balance to measure mass or a ruler to use to measure length, there are always going to be limitations in every instrument that you use to measure something, just how it is. There's no such thing as a perfect measurement tool at all. So a limitation in the instrument is going to affect the overall precision of that instrument, or in other words, the number of possible digits that can be recorded for that measurement. Now, the possible digits that can be recorded for any measurement, we call them significant figures. Sig figs for short. Each measurement will always include certain digits that everyone will agree on. So if I look at one of your measurements and someone else, like your lab partner or a friend, look at your measurements, we will all agree on certain digits and we'll say that those are true digits. But then you're also going to estimate one certain or one uncertain or estimated digit. All right? That estimated or uncertain digit is the last digit in your measurement. And we're not going to agree on it, but that's okay. So all of these digits that you use for a measurement are called significant figures. Right? In a nutshell, this is what significant figures are. When recording the correct number of digits for any measurement, always include all the certain digits that everyone will agree on, plus the one estimated digit that we will not or may not agree on. And that estimated digit, remember, always comes at the end of a measurement. Alright, so let's take a closer look at a real example of this. Here we have what is known as a graduated cylinder. A graduated cylinder is a measuring instrument that's used to determine the volume of a liquid. Right? So we have some kind of liquid in this graduated cylinder, and we're going to determine the number of digits that we need to record to give us the correct number of significant figures for this volume of liquid. So they were nice. They kind of zoomed in here so we can take a closer look. Looking at this, it would assume that our measurement or our volume is in between 20 and 15. Alright? And it also looks like that we are going up by 1. So we got 15. This one, this hash mark is 16, 17, 18, 19, and then 20. Okay? So our liquid appears to be between 17 and 18. So it's definitely 17, but it's not quite 18. So what we would say is we would all agree that the volume of this liquid is at least 17 milliliters. So I'm going to write down 17. Now, because it becomes in between 17 and 18, we're not really sure what that next digit is. So our next digit has to be our estimated digit. So because it's between 17 and 18, it's going to be a fraction or a decimal point between 17 and 18. And so my estimation is going to be 17.8 milliliters. All right? Now, you might have said 17.9 milliliters. Someone else might have also said 17.7 milliliters. All right? Are we wrong? No, because we all agree that the volume is at least 17. So we all agree on the 17. But what we might disagree on is the last digit, which is okay because the last digit of any measurement is estimated. It's uncertain. We're not sure what it is, but we can take a good guess. And 0.8, 0.9, or 0.7 are pretty good guesses for this particular measuring device or instrument. All right? Let's do another one. All right, here's another graduated cylinder. Now this one is an actual real graduated cylinder with a real liquid in it. And so if we look really closely, we can see that we have the 50 mark and we have the 60 mark right there. And so if we go and count, it looks like it's going up by 1. So we have 50, this would be 51, 52, 53, 54, 55, 56, 7, 8, 9, and 60. So it's all going up by 1s. Alright? So it looks like, and by the way, in a graduated cylinder, the way you measure the volume in a graduated cylinder is at the bottom of the meniscus. You'll see that it kind of bows here. Let's see if I can kind of trace the bow. Actually, it's not that great, but let me try it again. Okay. There, that's a little bit better. Okay, notice it bows a little bit. That's common in graduated cylinders. And so you're going to determine the volume at the very bottom of this bow right here. Okay, whatever that is. Okay, so here let me erase that and let me make this a little bit here. Oops. Alright, something like that. So this mark here is 50, this is 51, and this is 52. Alright, so what we should agree on is that the volume of this liquid is at least 52 milliliters. Alright, but can we estimate a digit? Absolutely. After 52, of course, is 53, which is right there. Now it looks like the liquid, it just, and if I erase this line to make it look better, okay, so here's 52. And this is 53. So to me, it's just right under 53. So I'm going to estimate 52. Let's see, 52 point, I'm going to say 9 milliliters. All right. Now you might estimate that it was 52.8 milliliters. All right. Is that okay? Absolutely, because we both agree on the first two digits. And we agree that those first two digits are certain and true. And then our last digit, that's where we disagree on. And that's exactly where we're supposed to disagree, is on that very last digit, our estimated digit. So again, to remind you, to recap, significant figures are all the digits that are recorded in a measurement. To record the correct number of significant figures, you must include all the certain digits that we agree on, plus the last digit, which must be uncertain or estimated. And we're not going to agree on it. Just like in here. We may not agree with that. Alright? Awesome. Alright, so now what we're going to do is we're going to look at some specific rules to significant figures. We have to have some rules because of zeros. Zeros can give us a problem. So when we're looking at a measurement and we look at zeros, sometimes zeros in a measurement are really not significant digits, Instead, they're just placeholders to give us some meaning to our measurement. So we need to determine if a 0 is really a significant figure or a significant digit, or if it's just a placeholder. So here are 4 rules that we're going to start with. Number 1, all non-zero digits are significant. So anytime you see a measurement and it has all numbers that are not 0, they're all going to be significant digits. So here's our example. We have the number 123 grams. So we measured that out. So we can look at that and we can be certain that 123 are significant digits. So I'm going to actually just write again 123 grams here. Alright, so according to significant figure rules, which digit, the 1, 2, or 3, is going to be our estimated digit, or the digit that we might not agree on in this measurement? If you said 3, you would be correct. 3, our last digit, is our estimated digit. We should all agree, if we made this measurement, we would all agree on the 1 and the 2. But the 3 we might disagree with. It might actually be 1.24. Alright? And that's okay, as long as we agree on the first 2. Alright, let's look at rule number 2. If the 0 precedes the first non-zero digit, they are not significant. For example, we have a measurement here of 0.00012 meters. Alright, these zeros here are not significant because, according to this rule, zeros that come at the beginning of a number, they are not significant. Instead, these zeros are considered placeholders. We have another one here too. We have 2 other zeros that become before a number, and so those zeros are also not significant whatsoever. Alright, so what this measurement tells us here, I'm going to actually enlarge this. So we got 0.000 and then 1 and a 2. Okay, so if these zeros are not significant, alright, which number, the 1 and 2, which are significant, is our estimated digit? You should say the 2. The 2 is our estimated digit. It's the one we will not agree on. The 1 we should agree on, but the number 2 we won't agree on. Alright, so in this case, this measurement only has 2 significant figures. In the other example right here, how many significant figures are there? If you said 1, you would be correct because the zeros are not significant. So that measurement has 1 significant digit, and the 1, being the only digit, is our estimated digit. So we don't necessarily agree that that really is a 1 or not. Alright? Alright, let's go to rule number 3. In rule number 3, it says if the zeros are between non-zero digits, then they are significant. So for example, we have 40.103 kilograms. We have 2 zeros, and both those zeros come between non-zero digits. So those zeros are significant. So that gives us 5 significant figures in our overall answer, with the 3 in that measurement being our estimated digit. Here's another example. In this one we have 0.0503. So we have 2 zeros that come at the beginning of a number. Are they significant? No, they're not, because of rule number 2. But the 0 in between the 5 and the 3 is significant, and therefore we have a total of 3 significant figures in this number or measurement, with the 3 again being estimated. Alright, let's look at the number 4, rule number 4 here. It says if the zeros follow non-zero digits, they are significant only if a decimal point is given. So for instance, we have a measurement here where we have 2 zeros at the end of the number. So we have 400 milliliters. All right. Now 400 follows by a decimal point. So according to this rule, those 2 zeros are significant because there's a decimal point there. So we'd say it has 3 significant digits. But look at the other one. We have 400 milliliters, but it has no decimal point. Okay, there's no decimal point there. Because there's not a decimal point, those 2 zeros are not significant, and therefore we will only have one significant figure in that measurement. All right? So let me give you a few more examples of this idea here. So let me pull out a whiteboard. Let me erase all of this. You can kind of use this a little bit. All right, so let's say we have a measurement of 300. All right. Now the question is, are these zeros significant? The answer should be no. And the reason why is because there's no decimal place. So there should be only one significant figure, or what we call sig figs. And the 3 should be our estimated digit then. Alright? However, if I did 300 and then I put a decimal point there, now those zeros become significant and I have 3 sig figs. So if I have 3 significant digits, which one of those digits, the 3, the middle 0, or the last 0, is my estimated digit? If you said the last 0, you would be correct. The last 0 is estimated. It's not certain. But the 3, this 3, and the second 0 are significant, and we know those to be true. Alright? So we're going to play a lot more with significant figures in class. We're going to practice this. Some students pick up on significant figures really quick. Others, it takes a little bit of time, and that's okay. You might need to kind of go back and review this lecture video a little bit on significant figures, especially this part on the significant figure rules. What I really want you to do is come to class knowing rules 1 through 4. Alright? And if you know rules 1 through 4 and the definition of significant figures, you're going to be really good for the quiz on this part. I know we have 2 other rules, Rule 5 and Rule 6. Those 2 rules we're going to actually cover in class because I think a class setting is better for that. Alright? So that is it for this lecture.